2, 1.
Hi, and welcome to Triana News. Today we will be talking about Vitruvius, who lived approximately 85 BC to 20 BC. He was a Roman who studied architecture. He is most famous for his Volume 10 Britain collection and architecture. Vitruvius introduced his theories about the human body that had not been considered before his time. Vitruvius described the dimensions of the human body. During the Renaissance, his theory was illustrated by the artist and scientist Leonardo da Vinci in the year 1490. Leonardo da Vinci's drawing, Vitruvian Man, shows how the proportions of the human body fit perfectly into a circle or square. The dimensions of the Vitruvian Man are used extensively in figure drawing. The purpose of this experiment was to test the theory proposed by Vitruvius. That gave 6 examples of proportional body dimensions. The first of these examples is that a person's arm span is equal to his or her height. Next, Vitruvius said, from the roots of the hair to the bottom of the chin is the 10th of a person's height. Another proportion that Vitruvius purported was the distance from the bottom of the chin to the nose, and from the roots of the hair to the eyebrows should be equal, each comprising of 1/3 of the length of the face. From the bottom of the knee to the bottom of the foot is equal to 1/4 of a person's height, according to Vitruvius. Lastly, Vitruvius said the distance from the outer edge of one shoulder to the outer edge of another shoulder is equal to 1/4 of a person's height.
1.
This just in. The scientists hypothesized that if measurements are taken of a human body and compared to Vitruvius' proportional body dimension theory, then the person will not be proportional. If this experiment is conducted correctly, there should be a little error. However, one factor that could lead to error is inaccuracy of the measurements. Another factor could be inconsistency in the measuring tool. The fifth person was measured with her cloth measuring tape, while the others were measured with the metal carpenter's tape measure. This might lead to discrepancy in the measurements of four to the other, but not in the measurements of each person when compared to his or her own measurements. Difference in body types also may lead in errors in the measurement. For example, it becomes more difficult to ascertain where landmarks for measuring are in a person of higher weight. It may be easier to measure the height of such an individual than it is to measure shoulder to shoulder. If it is harder to measure some landmarks than others, there will be an error in measurements of that person. The data in question 4 does not appear to be adequate because it leaves such little room on face for the nose. Perhaps these measurements were not taken correctly. How does boldness affect the measurement of the top third of the face? Subject 1 was bald. Also, how do variations in hairlines affect the data?
For this experiment, the researcher hypothesis was if measurements are taken of a person's body and compared to Vitruvius's proportional body dimensions theory, then the person will not be proportional. 5 sets of data were taken to test Vitruvius's theory. All 6 sets of data were taken from 5 subjects and compared to the proportions proposed by Vitruvius. The data were used to obtain a ratio for each person with each question. According to the data shown, the experimenter's hypothesis is proven. In all 6 questions posed by this study, the data reflects, at least in one family, Vitruvius's man's proportions are not as exact as the actual proportions of these individuals. Chart 1 shows the data obtained for the first question. The arm span to height comparison showed 80% of the subjects had the same arm span and height measurement. The other 2 subjects are close to the ratio of 1 with ratios of 0.99 and 1.05. Although the difference is small, this question is answered with a no. The data for question 2, shown in chart 2, once again shows proportions unequal to Vitruvius's man. For the proportions to be the same as Vitruvius's man, the ratio would be 1.0. The subjects appeared to have longer faces than Vitruvius's man, with each having a ratio longer than 1.0. Therefore, the answer to question 2 is no. Once again, the experimenter's hypothesis is proven. Chart 3 shows the data for question 3. Just as the individuals in this study appeared to have longer faces than Vitruvius's man, they also have longer heads. All of the individuals are above the 1.0 ratio needed to establish Vitruvius's stated proportion. The experimenter's hypothesis is proven by the statistics in chart 3. Question 4 has to do with the proportions within each individual's face. Vitruvius's man has proportions that make each third of his face equal to each other third. In this study, for an individual to have Vitruvius's man's proportions, the ratio must be 1/3 or 0.33. Looking at the data for these individuals makes the experimenter wonder, where is the space for their nose? The difficulty in establishing landmarks for measurement may have resulted in the data for this question. When added, the totals for 2/3 of each individual's faces are 0.76, 0.99, 0.81, 0.87, and 0.72. The faces are not proportional in this study. Therefore, the experimenter's hypothesis is proven by the statistics in Chart 4. Apparently, the individuals in this study have longer femurs than Vitruvius's man. The data in Chart 5 shows that every individual in this study has a longer femur than anticipated by Vitruvius. According to the National Institute for Health, the length of the femur is affected by nutrition and disease. Therefore, it is not surprising that modern humans have evolved since Roman times. Once again, the data shows the ratios larger than 1.0 for these individuals. Chart 4 proves the experimenter's hypothesis. The data for question 6 shows one subject has the 1.0 ratio needed to confirm Vitruvius's theory. Of the other 4 subjects, 3 have slightly less than the 1.0 ratio needed, while 1 has more than the 1.0. Once again, the answer to the question 6 is no. The subjects in this study do not have the same shoulder-to-shoulder proportion as Vitruvius's man. It should not be surprising that Vitruvius's man is hard to replicate. Vitruvius's man is the ideal man. No doubt, as part of the Roman army, Vitruvius saw many examples of fitness. Those individuals who had disproportionate bodies may have been unable to join the Roman army. His proportions reflect those art teacher used to teach drawing or sculpting. With human evolution, various parts of the body change. This change comes about through environment, genes, and disease. As demonstrated in this experiment, all individuals do not have the same perfect proportion seen and suggested by Vitruvius.